started. Yeah. Okay. Going back, way back. Remember, I hope you remember that I told you that we need to make sure that we are understanding all of the material because we're going to be using it almost throughout the entire calculus, almost throughout the entire year. We're going to be using limits the remainder of the semester, so we need to make sure that we understand limits. If you don't understand limits, I have office hours Monday after school, Wednesday morning. Mr. Esquivel has them Monday before and after school. Okay? You can also go to Ms. Ravello. Ms. Ravello is my other co-teacher. She understands this also. She can help you out. So make sure you're going. All right, what do I do with the 0? Substitute for what? So we have 3 times 0 minus 7. Please let me know if I'm going too fast, but we've done this before. And that gives me -7. Snaps or hands. Thank you. Shush, shush. Okay. So then what do I do with this 1? For what? How many x's? 2. So you have 1 squared minus 9 times 1 plus 10. And that gives me 2. Snaps or hands. Am I going too fast? Are you sure? Okay. Let's look at the number 3. What do I do with the 6? Substitute for how many x's now? 3. So we have 6 squared minus 9 times 6 plus 7. Sorry, I forgot to put these in parentheses. Over 2 times 6 plus 1. And I believe that gives you -11 over 13. Thank you. All right, am I going too fast? Are we sure? Is this coming back to us? Good. Good. All right. Oh, sorry. Can I go? Does everybody have that? Yes, 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 yes. Okay. Look at Crystal trying to. What can I do to the top and bottom here before I substitute in? Cancel out. For those of you who substituted in first, you should have gotten an error, or your calculator should say cannot divide by 0. Right? So remember, when it says any of that, you have to factor or cross things out. So I'm going to substitute in 3 to the x, and we got 3 plus 2, and that equals 5. Questions? Snaps to the students who are looking back at their old quizzes and their old notes for the X method. Good job. That's why I told you try not to throw anything out because you'll need it. So when you substituted -4, you got an error, yes? So we need to factor the numerator. When we factor the numerator, we'll get x plus 4, x plus 4, 4, over x plus 4. What can I do? Cancel out. So then I'll have oops, sorry, I'm moving too fast. X plus 4. What do I substitute in for x? -4, so we have -4 plus 4, and that gives me 0. If you don't remember how to factor using the X method or any other methods, come to our office hours and we'll help you. You will need to make sure you understand the X method also. All right, last but not least, you would also get error on this one. So you need to factor. We have x plus 6, x minus 3, over x plus 9, x minus 3. What should I do? Cancel. And then substitute in. So we have 3 plus 6 over 3 plus 9. And that would give you, I think, 3/4. Can somebody put it in their calculator to double check? For favor. Okay. When you're done with this, put this away and take out your notes. If you need paper, paper is in the front where it always is. in the do now bin all the way at the bottom. Okay. Everybody got their notes out? Or a piece of paper?
Miss, can I send the phone so like get the notes better?
Yeah. You can sit next to me, go. Alright. Okay, here we go. Today is the 4th. We're going to be working with something called the difference quotient. We'll be working with something called the difference quotient. Gentlemen. Oh. Okay. All right. So before we get to the difference quotient, we need some vocabulary. Average rate of change. We were working with this in our word problems. We did this before break without word problems. Remember that average rate, do we remember that AROC is average rate of change? No? You want me to write it out? Yeah? Okay. That's okay. Average rate of change. So the average rate of change is the rate of change or slope or unit rate over an interval, meaning 2 points. So we were doing average rate of change in those word problems. Way before break, we did average rate of change with functions and graphs and coordinates. And then we moved on to word problems. Same thing, average rate of change, we need 2 points to find the slope between two things. However, in calculus, we don't care about what's happening between two things. What we care about in calculus is what happens at one particular second. In physics, you guys took physics last year, right? Well, not you, but you did or no? Okay, so you took physics, doesn't matter. Everybody took physics?
Yes.
Okay. When you were calculating velocity and acceleration, that was at a particular instant. At a particular instant. Not over a number of instances, it was at a particular instant. So, in calculus, we also care about a particular instant. That is called the instantaneous rate of change. The instantaneous rate of change is the rate of change, just like the average rate of change, slope, etc. But not over an interval, not between 2 points. It's at one particular value. Just one. We don't care between two things. We just care about what happens at that one instant. In calculus, 99% of the time, the instantaneous rate of change, so I'm abbreviating, may not be the same for each value. It may not be the same for each value. 99% of the time it won't. There are only two instances it will be, and we will rarely do those. Those will be constant functions and linear functions. But because we don't have 2 points, we cannot find, it's because it dimmed out there, so it looked like it dimmed in here. I saw your face. Because we don't have 2 points, we cannot find the rate of change using the slope formula. We can't do that. So we have to use something called the difference quotient. Oops, I spelled quotient wrong. Sorry. The difference quotient. The difference quotient is the formula that gives the equation to find the instantaneous rate of change at one value. Can I move up? Angie? Can I move up? Yeah. Somebody's out right now. Yeah. Okay, I'm going to give you the formula. It's going to look weird, but I'll explain it, okay? So the formula to find the difference quotient is as follows. Formula. The limit. See why I had you review limits? As h approaches 0 of f of x. Oops, wait, nope. Plus h minus f of x all over h. Yes, I know that looks very confusing, and I know that looks like a lot. And I'm not going to lie. It's going to be for level 2, 3, and 4, okay? But if we just remember our algebra, we should be fine. Oh, Miss Santana. Yeah, well. Okay. Everybody have that down? Yeah? No? Maybe so? I still see people writing. I'll just wait. Alex, you almost ready? Okay. Good? Okay. Everybody ready? All right. So before we get into the example, I want to give you steps. I'm going to try to give you as much detailed steps as possible, so when we get to the examples, you can follow the steps. Okay? All right, so steps to find the difference quotient. I'm abbreviating. DQ, difference quotient, not the ice cream shop. Difference quotient. Thanks, Crystal, for laughing. Okay. You're going to take the difference quotient in pieces, in parts. Because if you try to do it all at once, it's going to get complicated and messy. So I broke it down so that this way you have it in parts. So the first step is to simplify f of x plus h. Okay? What this means is we have some value inside of our function. We need to substitute in x plus h for every x. Every x. 1x, 2x's, 3x's. Substitute in x plus h for every single x. Okay? I've seen students get almost all the way there and they forgot to substitute in one of the x's. Make sure you're subbing in all the x's, okay? All of them. When you do that, you're going to need to simplify. That means you might need to distribute. That means you might need to combine like terms. If there are any, okay? So it's not simply just substituting in. You've got to try to simplify as much as possible because it will make all the remaining steps easier. Step 2. You're going to simplify the expression f of x plus h minus f of x. You've done x plus h already in step 1. So you don't have to do it again. This is why we're breaking it down. You don't have to redo this because you've already found it in step 1. Bless you. Minus the original function. This is going to be your original. That's going to be your original function. Does everybody have this top part down? Okay, I'll go down. This is your original function, which means that after you have substituted in the x plus h, so you're going to sub in step 1. You're going to need to distribute the negative sign. You'll see what I mean in a minute. So you're going to need to distribute the negative sign. So technically there are parentheses around this. Technically there are parentheses around this. And again, you want to simplify as much as possible. Again, this may mean to combine like terms or distribute. Step 3. You need to simplify. Oops, I did that backwards. Or find, doesn't matter. F of x plus h minus f of x over h. But guess what? You've already done this part in step 3. So you don't have to do it again. This is why we're breaking it down step by step. What's wrong? Oh, you're right. Step 2. Thank you. I'm on step 3. My bad. Step 2. That looks gross. There. Is that better? Okay. Step 2. Now here, again, combine like terms. And one other thing you're going to need to do, you might need to factor an h. Factor any h's. You need to factor out any h's. Because then you'll need to cancel out the h's. And then last but not least, Tanosh, did you go to the bathroom already? Oh, that's right. Can you want me to call? Okay. Hi, Kimberly went to the bathroom and hasn't come back yet. Okay, thanks. Bye. Okay. The last thing you're going to do is find the limit as h approaches 0 of f of x plus h minus f of x all over h. Guess what? You did this already in step 3. Oh, okay. You did that already in step 3. Remember, to find the limit, you're going to need to sub in. What are you going to substitute in? What are we subbing in? Not O. 0. Substitute in 0 for each h. Okay? Substitute in 0 for any additional h's. All right, are we ready for example? I still see people writing, that's okay. So the first example is going to be level 1. Tomorrow you're going to have practice on level 1 and 2 and have a 2-question exit ticket at the end of class. Ready? Okay. All right, so example 1. Level 1. We need to find the equation for the instantaneous rate of change. given the function f of x is equal to 4x minus 2. Okay. What did step 1 tell us we need to do? What's step 1 tell us? Sub in x plus h. For what? Every x. How many x's do we have here? We have, well, nope, not that one. We're talking about this. 1. We have 1. So it's going to be 4 times the quantity x plus h minus 2. Remember that our notes say that we need to simplify as much as possible. That means to distribute. That means to combine like terms. Should we distribute here? Can we distribute here? Yes. What am I distributing? The what? The 4. I heard somebody whisper. So I'm going to distribute the 4 to the x and the 4 to the h. So I have 4x plus 4h minus 2. Questions? Questions? Okay. What does step 2 tell us we need to do? Oh, wait, sorry. Can I combine like terms? No, there are no like terms. So I'm left with 4x plus 4h minus 2. What does step 2 tell us we need to do? Find f of x plus h minus f of x. Remember, this is in parentheses. But I have 4x plus h. What is that? It's 4x plus 4h, Miss Santana, minus 2. Yes, you're right. What is f of x plus h? I'm sorry, not f of x. What's f of x? Not a trick question. What's f of x? Well, yes, it is y. But what specifically is it in this problem? What is the original problem? 4x minus 2. Oh. Remember, did I put that in your notes, that it was the original equation? Yes. Okay, so make sure you're using your notes. What do my notes say I need to do next to this? Distribute. Yes, we need to distribute. Why are we just not saying it louder? So we're going to distribute. All we're doing here is distributing this negative 1. So positive becomes negative, negative becomes positive. So we have 4x plus 4h minus 2 minus 4x plus 2. I just distributed the negative, which made their signs opposite. Okay. What else does step 2 tell me to do? Simplify. So we need to simplify by combining like terms. Oops, that's not 4h. I mean 4x. What is this? Sorry. 4h. My bad. Do I have any like terms here? Yes. What are my like terms? 4x and negative 4x. So that cancels out. What else is like terms? Negative 2 and 2. So I'm left with just 4h. What's wrong? Did I do something wrong?
No, what are you saying is you lost it?
It is. It is. It's but we need to understand this before we get to the instant. Yes, yes, yes. We're probably going to be on this until the end, until Christmas. It's just because I need you to understand this. Okay. Anyway, what does step 3 say? What does step 3 say? Fine. F of x plus h minus f of x divided by h. Good. What do we know this f of x plus h minus f of x is? Where do we get this from? Where do we get this from? Step 2. So here, we're just going to replace 4h over h. Do I need to do any factoring? Or combining like terms? No, there's nothing to factor or any terms to, thank you. So then what should I do? What does it tell me to do after I've done that? What does that tell me to do? Cancel out the h. So I only have one h here, so I'll cancel it out. And my last step says to find the limit. So we have the limit as h approaches 0 of all of this. But we did that in step 3. Who remembers what the derivative of a constant is? Sorry, not derivative. Did I say derivative? Yeah. Limit of a constant. We don't remember, huh? Can I substitute in any h's? No. So it's just this number. So our final answer is 4. Miss Santana, we had to do all that for 4? Yes. Yes, we did. Bruh. Yes, we did. Bruh. What? What'd you say? Why is it concern? This is level 1. Questions?
Why did you cancel out everything on the top of it?
This? Because they're like terms. We have 4x minus 4x. That'll be 0. Negative 2 plus 2 is 0. Okay? Make sense? No? Yes? Okay. Everybody have level 1 down? Yes. All right, let's go to level 2. All right. Somebody not? Okay. Level 2. Okay, let's take it step by step. First step. What do? You forgot. You have your notes. Go back and look in your notes. Huh? No. Look at your notes. Substitute what? Yeah. So how many x's?
I write it down.
2. So we're going to substitute in. Because there's this square, we need to make sure that we're using parentheses. Okay. What does this square tell me about this part of the equation? What does the square tell me? What? It's doubled, right? So there are two of these things. So it's x plus h, x plus h. What can I do to this negative 9? Distribute. So I have negative 9x minus 9h plus 3. What should we do here? What should we do here? What would you do in algebra if you had this? You don't know? Nope, can't cancel. What? I know you. I heard what you said. Sam, what'd you say? Okay, whatever. What would you do to this if you saw this? If it was like x plus 2, x plus 4, what would you do? Can't divide. No. Combine. How do you combine it? Okay. Whew. We're going to need to practice this. We need to FOIL this out. Do you remember foiling? Okay. Box method? Yes. Okay. We're going to have to do box method? For real, box method? Okay. X, H, X, H. Yeah, because there are two things. Yeah. I think that's too much, but okay. So we have x squared, xh, xh, h squared. What am I doing inside each of these boxes? No. What? Multiplying. Thank you, Udia. Multiplying. We're going to multiply. X times x is x squared. X times h is xh. X times it, xh. H times h, h squared. Now we can combine like terms. What are the two like terms that I have? xh. So that gives me x squared plus 2xh plus h squared minus 9x minus 9h plus 3. I can smack my lips too. Can we combine like terms? Did I ask that already? Where? What are like terms? No, we can't. There are no like terms here, so we can't combine like terms. So then we move on to step 2. Step 2 says to find f of x plus h minus f of x. So we already have f of x plus h. Minus, what is f of x? Not a trick question. What's f of x? Remember, f of x is your original equation. What is my original equation? X squared minus 9x plus 3. What do I do to this negative sign? What do I do to this negative? Distribute. Remember, it is like a negative 1. So we have x squared plus 2xh plus h squared minus 9x minus 9h plus 3 minus x squared plus 9x minus 3. Believe me, your quizzes are not going to have tons of problems. It's probably going to have 2 problems. Okay?
Okay, we're good.
Okay, don't worry. Don't worry, don't worry, don't worry. Where did I get what from? The number in the parentheses. Remember, the number in the parentheses is your original gentlemen, ladies. We need to stop complaining about how hard this is and pay attention. Yes, it's going to be a lot of work. This is calculus. This is not 8th grade math. Sam, did you see where I got it from?
Yeah, it's the original.
Okay.
Yeah, I figured it out.
All right. Do I have like terms? -3, +3. Cancel those out. X squared, X squared. 9x, 9x. What'd you say? Thank you so much. I appreciate you. So, there are no more like terms. So I have 2xh plus h squared minus 9. What, Crystal? Oh, that should be 9h. My bad. Okay. Am I done? No, what does it say I need to do then? Not yet. Not yet. Not distribute. We need to factor out any h's. What'd you say? Okay, so I need to factor out the h's. Each of these has an h in it. So I have 2x. I take out one h. So there's no more h's left. Okay? I take out one h, right? That means I have one more in there. I take out one h. Minus 9. Step 2 is done. Step 3. I'm going to rush this a little bit because we've got 6 minutes. Yep. Okay. We need to put this over what? Over h. So we have h. 2x plus h minus 9 over h. What did my notes tell me I need to do? Cancel out. So I can cancel out these h's. Do I have any more h's I can cancel out?
Yeah.
Nope, because I'm left with only this. Because when I cancel out these h's, they go away, right? So then I'm only left with this. Do I have any more h's I can cancel out? No. All right, last thing, to find the limit. What? What do I do with the 0? Sub it in for what? For h. We only have one h, so it's going to be 2x plus 0 minus 9, which is just 2x minus 9. How? What's wrong? What do you have? All right, I know this is a lot of to process. Tomorrow we're going to have practice time.